Assalamualaikum and welcome to BFC 15003 calculus. In this video, we will learn about differentiation of logarithmic and exponential function. Okay. So basically, some of the things that we should remember, okay, when we are dealing with a logarithmic function is that we know that ln, or also known as natural log, it is equal to log base e. Okay, so for example, if we write ln x, it is equal to log base ex. Okay, so another thing is we know that ln 1 is equal to 0 and ln exponential, it is equal to 1. So basically, this is some of the things that we have to remember when we are solving the logarithmic or exponential function. Okay. Okay, let's take a look. This is some of the formula, okay, of ln and log that we need to remember. Okay, for example, if we have ln xy, okay, ln in bracket xy, it is the same thing, or we can write it as ln x plus ln y. Okay, so if we have ln x over y, okay, it is equal to ln x minus ln y. Okay, so if we have ln x power of r, okay, we can bring the r in front of the ln x. So we can write it as r ln x. Okay, same thing, okay, same goes to log. Okay, it is the same thing, ln and log. If you notice, if you can see, the formula is just the same. Okay, for example, we have here log a power of 2, then we can bring the 2 in front of log a. Okay, so okay, this one, okay, this is some of the basic thing that we have to remember. Okay, so if we differentiate ln x, okay, it is equal to 1 over x. Okay, we differentiate ln x with respect to x, so we will get 1 over x. Okay, so if we differentiate ln u with respect to x, we will get 1 over u times du dx. Okay, the same thing if we differentiate ln y with respect to x, so we will get 1 over y dy dx. Okay, okay, this is on the right, we can see this is for log. Okay, if we differentiate log base ax, okay, with respect to x, we will get 1 over x log base ae. Okay, if we differentiate log base au with respect to x, then we will get 1 over u log base ae times with du dx. So let's see the first example. Okay, if we are given a function of y equal to ln 3x minus 1. Okay, so from this logarithmic function, we can see that we can solve this one by using chain rule, isn't it? So this one, okay, we will assume 3x minus 1 as u. Okay, so we just write on the right here, u is equal to 3x minus 1. Okay, so du dx, we will get 3. Okay, so therefore our y now become y is equal to ln u. Okay, so dy du, okay, we will get 1 over u because we differentiate it in term with respect to u. Okay, so we know that the formula of chain rule, Okay, when we differentiate this function, okay, we will get dy dx, it is equal to dy over du, okay, times with du over dx. Okay, so therefore we just substitute, we will get 1 over u times 3. Okay, and then we just substitute back the value of u, which is 1 over 3x minus 1 times 3. Okay, so therefore we can just simply write 3 over 3x minus 1. Okay, so this is the answer. Let's see the second example. If we are given a function of y equal to ln square root, okay, so 1 plus 2x divided by 1 minus 2x. Okay, how can we solve this one? Okay, we can rearrange, or we can rewrite this logarithmic function as ln in bracket 1 plus 2x divided by 1 minus 2x power of 1 over 2. Okay, so power of 1 over 2. Okay, so this one, if you remember from the formula, it is the same thing. If we write, there is the same ln x power of r. Okay, we can rewrite it as r ln x. Okay, we can apply this formula, okay, so that it will become 1 over 2 ln 1 plus 2x over 1 minus 2x. Okay, so now here, if you remember, this one, it is the same with this formula, ln a over b. So it is the same if we just write ln a minus ln b. Okay, so now we can rewrite or rearrange this thing. Then we will get 1 over 2, okay, in bracket ln 1 plus 2x minus ln 1 minus 2x. Okay, so now we want to differentiate this function. Okay, so we differentiate dy over dx. We just write back 1 over 2. Okay, when we differentiate ln, we will get 1 over in bracket 1 plus 2x, and we need to differentiate the one in the bracket time with 2. Okay, minus 1 over 1 minus 2x, and we need to differentiate the one in the bracket, and we have to time x. So negative 2. When differentiate 1 minus 2x, we will get negative 2. Okay. All right. So now we can simplify. Okay. We can simplify this one. Okay. And finally, we will get the answer will be 1 over 1 plus 2x plus 1 over 1 minus 2x. Okay, right, and we will get 2 over 1 minus 4x squared. Okay, so therefore, this is the answer. Okay, let's see the third example. Okay, the third example. If we are given a function of x, power of x, okay, and then we have to differentiate this function with respect to x. Okay, so how can we solve this one? Okay, this is a y equal to x power of x. We can solve this function by using a derivative of logarithmic function. Okay, where we can multiply both sides with ln. Okay, we need to differentiate both sides. So this one on the right side, I can rearrange. Okay, I can rearrange as x times ln x. Okay, because we can bring this one in front. Okay, now differentiate ln y with respect to x. We will get 1 over y dy dx. Okay. Okay. Now differentiate x ln x. Okay, this one we can use it. We can solve it by using product rule. Okay, this one will be u and this one will be v. All right. So we know that u is equal to x. So du dx will be 1. Okay, so v is equal to ln x, so dv dx, we will get 1 over x. Okay, so when we use product rule, okay, we will get 1 times with ln x plus x times with 1 over x. Okay. All right. So now, finally, okay, the answer will be, we just time, okay. Now we just, this one we can cancel off. Okay, so now we can get, we just time both sides with y. Okay, we can just time both sides with y. So dy dx now will become y time with ln x plus 1. Okay, since y is equal to x power of x, you also can write it as x power of x in bracket ln x plus 1. Okay, so this is the answer. We will continue the second part in another video.